All right, we have three problems that are, looks like volumes by cross sections. So the first one, we have a circle of radius A, and I'm going to draw this guy, and I like to put my circle right on the origin. So the radius here is A, and I'm perpendicular to A diameter. So choose the diameter wisely and choose the diameter that crosses through the x-axis. That way, everything you do is going to be perpendicular to the x-axis. So then you have squares. So here is the first square, or one square. Representative squares is what I'm building here. So if I have a circle with radius A, the equation of that circle is x squared plus y squared equals a squared. If I solve that for y, I'm going to get the square root of a squared minus x squared. But that is just going to give me the upper half of the circle. So to get the entire base of that square, I have to double the square root of a squared minus x squared for my integral. And so this is 2 times the square root of a squared minus x squared is the base of each square, and I have to square it for cross sections of squares. And my limits of integration go from negative a to a, so I have negative a to a. So to make my life easier, I'm actually going to use symmetry, and I'm going to double the integral from 0 to a. And then when I multiply out the square root, I end up here with 4 times a squared minus x squared dx. And I'm going to pull out the 4. Again, I'm trying to simplify my life. So I have 8 times the integral from 0 to a of a squared minus x squared dx. So let's integrate with respect to x. That means we're going to have 8 times a squared x minus x cubed over 3 from 0 to a. So let's evaluate. By plugging in a for x, I have a cubed minus a cubed over 3. And then when I plug in 0, that's all going to go to 0 there. So 8 times a cubed minus a cubed over 3 is 8 times 2/3 a cubed, which is 16 over 3 a cubed, and my answer is D.